All right, I gave you a practice assessment in class today. You can try to, again, work your way through what the assessment's going to look like when you take the test tomorrow. And I wanted to go through this, give you a chance to have this information at home so that you can check yourself as you go, make sure you're doing all this right. This is what the first set of questions on this assessment's going to look like. You got a table that has amounts of salt that have been added to a beaker of water and the corresponding boiling points that you get with each addition of salt. So with no salt in the water, the boiling point was 100.5. With 10 grams, it was 101.1. With 20 grams, 101.9, and so on. First thing we have to do, calculate the increase in boiling point for each step. And then we have to add that information to the table. So we're basically filling in this column right here. To get the boiling point increase, what we're going to do is we're going to take what's in this row and subtract from that the row above. So we're going to do 101.1 minus 100.5. 0.6 degrees Celsius for the first one. Then we're going to do those two rows and subtract it. So 101.9 minus 101.1 is 0.8 degrees Celsius. And then again, take this row and subtract what's above it. So 102.5 minus 101.9, 0.6. And then the next two rows, 103.2 minus 102.5, that's 0.7. And then subtract these two rows. 104.0 minus 103.2 is 0.8. Now we have to calculate the average increase for 10 grams of salt. So what we're going to have to do is add all these values together. It's the sum of our increases. Divided by the number of increases that we had. 1, 2, 3, 4, 5 of them. Let's add these all together real quick. 0.6 plus 0.8 plus 0.6 plus 0.7 plus 0.8 equals 3.5 divided by 5, 0.7 degrees Celsius is the average increase. In the same way we'd find any average. Add all the numbers together and divide by the number of numbers. In this case, we had 5 data points that we had to add together, so it's divided by 5. Now we're going to predict what the boiling point would be if 20 more grams were added. Now, these increments over here are all 10 grams. Every step has been 10 grams. So this average is the average per 10 grams. We want to add 20 more grams. We want to add 2 times this. So 0.7 times 2 is 1.4. We would expect to see a 1.4 degrees Celsius increase. Add that to the last value that we had, and we would predict a temperature of 105.4 degrees Celsius. And again, that's just utilizing the information that we have here. We know we left off at 104. We know that for every 10 grams, it seems to go up 0.7. So if we add 0.7 twice, or 2 times 0.7, 1.4, we should get the new temperature at 70 grams. The next part of the assessment asks you to graph all that data. First 2 columns, basically, where we're looking at the amount of salt versus the boiling point. We want to do everything that we were told to do. We want to title it. We want to make sure that we label our axes correctly. We know we have to put the independent variable down here on the x. We have to put the dependent variable over here on the y. So we have to ask ourselves, does the amount of salt affect the boiling point, or does the boiling point affect the amount of salt? What we're doing here is we're adding salt over and over again to see what happens. We want to see what the amount of salt does to the boiling point. We expect salt to cause a change in boiling point. Cause and effect. Cause is going to be the independent variable. The effect is going to be the dependent. I'm going to label the axes. We want to include the unit. The amount of salt is measured in grams. The boiling point is measured in degrees Celsius. We need to scale the axes. And again, if we don't know how to scale them, if we're not sure how we want to scale them, we look at the range of numbers. We take the range divided by the number of lines we're working with, and I'll give us a minimum idea of what we should do, of what the different lines should mean. For example, an amount of salt, we go from 0 to 50. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 lines. If I do 50 divided by 22, I end up with about 2.3. That's my minimum value per line. So I can go up by 3s, and that should all fit in there. Who does that? Probably be best to go up by 5s. Starting with 0, this one would be 5, this one would be 10, this will be 15, and 20, and 25, and 30, and 35, and 40, and 45, and 50. It's a little bit cramped. Yes, it could be spread out even more. We could have jumped 3 lines and again done it by 3s. There's a lot of different ways that we could have done this. But that's a reasonable, I guess, enough scale for us to work with here. On the boiling point side, our range is much smaller. We're going from 100.5 to 104. We're only going up 5 degrees. But we don't want to cram it into this little first 5, 4 lines that we've got. We want to spread it out a bit. We have some decimal values to deal with, so it's not a bad idea to spread it out a bit. We're not going to start at 0 here, so I'm going to put a break in there and start at probably 100, since 100.5 is our first number. Make that 100 degrees. And then I might go 2, 4, 6, 8, 101, 2, 4, 6, 8, 102, 2, 4, 6, 8, 2, 4, 6, 8, 103, 2, 4, 6, 8, that's too much. Went too far. That's not going to work. So now I'll try it by 0.5. So I'll start with 100. That'll be 100.5. This will be 101. 101.5, 102. 102.5, 103. 103.5, 104. 104.5, 105. And that fits. Now we've got all of our numbers where they need to be. We can start plotting points and putting in our line. At 0, we were at 100.5. There. At 10, we were at 101.1. So maybe there somewhere. At 20, we're at 101.9. Almost all the way to 102. At 30, we were at 102.5. There. And at 40, we were at 103.2. There, a little bit less than halfway. And at 40, we're at, or 50, we're at 104. So we're right in there. Draw a line of best fit to show the trend. and we're done with the graph. That's page 1 of our practice assessment.